Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in today's video, we are focusing on this Pure Math P1 paper. This is from October-November 2024 and the second variant, and this is the date today. So now some of the questions have been done. I'll go over it. So that will be kind of a walkthrough video, and some of the questions I'll solve it out. The threshold for this paper, I think it's 52 out of 75. That is the threshold for getting an A. And more or less, in all these three papers, the threshold was more or less the same. Either it was like 52, 53, 55 out of 75. So that's a pretty low threshold. Now, sometimes the threshold is low because the paper is difficult. Sometimes it's the people who are giving the paper, they're not so good. They have a weak basic. I think that was the case. Both were the cases in this one. The paper was also tough. So now this is 7:21 and we are starting now. This is 7:21 p.m. We are starting the paper. Question number 1. So now it says the diagram shows a curve with equation y is equals to a sine bx plus c. Let me just remove this line. A sine bx plus c for x between 0 and 2 pi, where a, b, c are positive constants. And now it says state the values of a, b, and c. Now, first of all, what we determine is that we have the maximum value, which is 7. We have the minimum value, that is -1. So the difference between maximum and minimum, half of that is the amplitude. So amplitude, A, the coefficient of the trig function for sine and cosine, we have this amplitude. And this amplitude is half the difference between the maximum and minimum. It's not the average, it's the difference. So this comes out to be 4. That means if the graph of only a sine x, a sine bx was to be made, the maximum value would have been 4, the minimum value would have been -4. But now we see that the maximum value is what? It is 7 and the minimum value is -1. That means the graph has been raised up by 3 units. That is evident from the maximum. That is evident from the minimum. So therefore, this constant that is being added for the vertical translation, because we also study function. So this constant that has been added is 3. This thing is done. Now, let's talk about the coefficient of x. So this b is the coefficient of x. We know that y is equals to sine bx. That means b cycles in 360 degrees. 360 degrees can also be written as 2 pi. So how many cycles do we see? We see one complete cycle, and then we see another cycle in 2 pi. So therefore, the value of b is 2. So I can write it by observation also. Since I see for myself there are 2 cycles in 360 degrees or 2 pi radians. So therefore, the value of b is 2. That's one way. Another way is over here. Let me just push this thing over here and let me draw a box around it. So now this is the alternative method. The alternative method is this. I see one cycle, the period is pi radians. So this is the period over here. Now the new period formula, it's 360 degrees divided by coefficient of x, which in this case is k. Or new period is 2 pi over the coefficient of x, which is not k, it's b in this case. So this is pi, this is 2 pi. You divide, you find the value of b. So there is this method over here. And then there is this method over here, which you can use to find the value of b. So these are 3 straightforward marks. Let's move ahead. So now the question says, for these values of a, b, and c, determine the number of solutions in the equation for x between 0 and 2 pi for each of the following equations. So this thing is the same as before, a sine bx plus c. That is the same thing as what is drawn over there. So let me highlight this thing. This is already drawn. This is already drawn. On the right-hand side, what do we have? We have 7 minus x. So since we have drawn y equals to this thing or fx equals to this thing, so now draw the line y is equals to 7 minus x. This is related to graphical solution of equation of O-level math. So now draw this line. For drawing this line, 2 points or 3 points is still better. If you're confident with your calculation, 2 points are good enough. So what I do is that when x is 0, let me erase all this stuff over here. And I think that's enough. So now if I want to draw this line, let me draw a box over here. Let me draw a line in the middle like this. So I'm drawing y is equals to 7 minus x. This is x, this is y. Now, if I want to take x is equals to 0, therefore y comes out to be 7. So one obvious point that is over here, 0, 7. That is one obvious point. And also remember this thing, that pi is 3.142. That's the value. 2 pi is 6.284. So now we will use approximate value for doing some calculation, because now the horizontal axis has pi in it. So let's say I take pi over here. So if I take x is equals to pi, therefore if x is pi, y is 7 minus pi, which is 7 minus 3.142, 7 minus 3.142. And just the approximate value, so that is 3 point, how much is that? 14, 15. Let me make it 15. So 3.858, something like this, 3.86. Now let me mark this particular point. So it's pi over here. And then 3.86 almost over here. That is the another point over here. So now you have 2 points. Just grab a line or a marker or whatever you feel convenient. Draw a line like this. And that's how this line is drawn, which is the green line, which is y is equals to 7 minus x. This is for B part 1. How many points of intersection do you see? I see 1, I see 2, I see 3, I see a 4th point, I see a 5 point. So basically, it's asking the number of solutions. That means number of points of intersection of 2 lines. That is basically what we are doing. So therefore, I don't know for some reason why I wrote 2. So there are 5 points of intersection. Therefore, there are 5 solutions. So I hope this thing is all good, all clear. Now over here, the next thing. Again, this thing is y is equals to 2 pi. This thing is y. And now they want us to draw 2 pi x minus 1. Either you can expand it or you cannot. So let me write it over here. Very obvious point. Let me draw a table over here. So I'm drawing a table over here. So that's a good idea to draw up a table. And let me just draw this line like this. And there is x, there is y. So always choose the value x is equals to 0. When x is equals to 0, that is 2 pi into minus 1. That is negative 6.284. That is not over here. I cannot pinpoint this thing because there are not that many negative value and I have to go all the way down. So now this value is useless. What if I plug in a middle value? Let's say I plug in pi. So this is 2 into, grab the calculator. And I think I have done something else. Let me put it over here. So this is y equals to 2 pi minus 1. So this is 2 into 6.284 into pi minus 1, that is 3.142 minus 1, that is 2.142. This comes out to be a big number. That is 26.92. That is 26.92. Now, what if I take y is equals to 0, I get x is equals to 1. That's a nice answer. So when y is equals to 0, x is equals to 1. So if I take x is equals to 1, then y is equals to 0. So let me mark this point. When x is equals to 1. Now, where do I mark x is equals to 1? We know that pi is 3.142. 3.142 divided by 2, that is 1.571. Pi over 2 is 1.571. Again, divide by 2. That is 0.7855. 0.7855. So pi over 4 is this value. Now, I'm looking for x is equals to 1. So it should be a little bit more than pi by 4. So a little bit more than pi by 4. So let me mark over here. This is pi by 4 and a little bit more. So something over here. That is one point that I have marked. And then there is one point that is way down there. So even if I don't draw, so if I just like draw something like this, it would be a very steep line. So I can just plug in one other point, which is of convenience. Let me choose a point which is pi by 2. No, I did not choose pi by 2. So let me just erase this point, and let me choose, this is also of no use because that's a very, very big value. So now let me choose this thing. Let me push this over here, push this over here. What if I choose pi by 2? If I choose pi by 2, this is 1.571. So the x coordinate would be over here, that is pi by 2. And then you can find the corresponding value. So therefore, y is equals to 2 pi by 2 minus 1. So this is 0.571. So this is 2 into 3.142 into this is 0.571. And maybe before I might have made some arithmetic error, but I've erased that point. So this is 3.588. I think this is good enough. So pi by 2 and 3.588, something like this. That's the other point. Now let's join these 2 points like this. Not exactly. Okay. So now this is a B part 2. Y is equals to 2 pi minus 1. I think that's the equation. 2 pi x minus 1, not pi minus 1, x minus 1. We were plugging in the values over here. So this is 2 pi x minus 1. That's a straight line. And how many points of intersection do we see? We only see one point of intersection. Therefore, in this case, there is one solution. Now, it's only worth 1 mark. But any which way, you have to draw it. So sometimes the difficult parts are labeled with very less marks. So the first question is done. Now let's move to the second question. The second question is the first term of an arithmetic progression. It's an AP. The first term is negative 20. Common difference is 5. Find the sum of the first 20 terms of this progression. Something very basic. A is negative 20. D is 5. N is 20. Sum of 20 terms. That is n divided by 2. 2a. That is 2a plus n minus 1. Which is 20 minus 1 into D, which is 5. Simplify, and then you get this answer, which is 550. The second part, it says it is given that the sum of the first k terms. So sum of the first 2k terms is 10 times the sum of the first k terms, and that is the ratio in between the two. It's 10 times. So first of all, if I focus on sum of first 2k terms, so n is basically 2k. If k is 5, 2k is 10. If k is 7, 2k is 14. So basically, in place of n, you write 2k. In place of n, you write 2k. Got the idea? That is sum of 2k terms. And then sum of first k terms. So you write k over here, you write k over here in place of n. So first of all, let me just highlight this thing. Let me just pick this thing, push a little bit to the side. Let me pick these 2 things. Let me copy it. And let me place it over here. I don't know, for some reason, let me write it down instead of wasting time. So A is equals to negative 20, D is equals to 5, N is equals to K. And then this thing goes over there. So this thing that goes over here. Okay. So I think that's how this thing is done. Now let's simplify both of them. So this is K, this is minus 40, this is 10K minus 5, this is K, and this is 10K minus 45. Leave it as it is for right now. Sum of K terms. So now this is 2, let it write as K over 2. This is minus 40 plus 5K minus 5. This is K over 2, 5K minus 45. Now it says sum of first two K terms that will come up later. Let me write it over here. So sum of first two K terms. So S2K, S2K is 10 times SK. So this is K bracket 10K minus 45 is equals to 10 times K over 2. And this is 5K minus 45. All good, all clear? So now if you want to get rid of K, you can get rid or you can take common, because we know that whenever there is a possibility of taking common, always take common, but K is equals to 0 is the solution that will vanish like I've done over here. So when you do this, that makes sense because K cannot be 0. You cannot have 0 terms in a series. So if I divide over here, what do I get? This is 20K minus 90. That is 50K minus 450. Got the idea? So 50 minus 20 minus 30K, that is 450 plus 90, 540 with a negative sign. And then you find the value of K, if I'm not mistaken, minus 450 plus 90. Hold for a second. So this is minus 450 plus 90. That comes out to be negative 360. So 30K negative is this thing. Therefore, K comes out to be 12. That's one way. Now, what if you did not divide and you took it as a quadratic, and then you take common, K is equals to 0, reject, because a series cannot have 0 terms, and you find the value of K as 12. So in this one, there was a possibility of common, but I did not take common. Instead, I divided. The reason for division was K is equals to 0. This solution is gone, but it does not make a difference because they cannot be a series with 0 terms. So that is the logic behind it. Now let's look at question number 3. Question number 3, that was a nice question. And for this one, I highly recommend that you go over the video which I have made earlier, that I shared earlier, that is about first principle of differentiation. So all I can do is to emphasize on it. You have to watch the video yourself, and then you have to understand. It was a very short video, but understand the logic, because that logic is fully applied over here. So now what is the logic? The logic is this thing. Let me get my marker ready. The equation of a curve is such, and this thing over here, the equation of a curve is such: 2 points A and B with x coordinates 2 and 2 plus h respectively lie on the curve. Find and simplify an expression for the gradient of the chord AB in terms of h. Now the concept is this thing. Let's say there is a curve like this, and there are 2 points on this curve. I've just drawn a portion of it. Let's say this is A. Let's say this is B. The x coordinate of A is 2, and the x coordinate of B is 2 plus h. And this is 2. That means this difference is h. And the rule is the closer B is to A, that tangent would behave as if it is part of the curve. So closer A and B are to each other, the better is the slope. Now, when x is 2, y is 5. That is the first point. So when x is 2, y is 5. So this is 2, and this is the y value, which is 5. Then when x is 2 plus h, the y value, after plugging in, after expansion and plugging in comes out to be this. So we have A, we have B, we have A, we have B. Then what I have done is that I have written it over here. So now I have A, I have B, gradient of AB, I am subtracting in this direction, y coordinate minus this y coordinate, the 5 and the 5 cancel out. This x coordinate minus this x coordinate, the 2 and the 2 cancel out. So we have 2h squared plus 8h divided by h. I took 2 common, I took h common, h plus 4 over h. So h cancel, 2 bracket h plus 4 or 2h plus 8 is also good. So that is the gradient. Now this is the $1 million question. That is about this thing. That what are they asking? Only for 2 marks. Explain how the gradient of the curve at the point A can be deduced from your answer to part A. Now your answer, gradient of AB, is in terms of h. How can you deduce it? Now the concept is, if A and B are very close to each other, that means this difference, this horizontal difference is almost 0. It's not exactly 0, it's almost 0. It's very, very close. Change in x is almost negligible. Change in x is h. H is 0. So if h is almost 0, 2 into 4 is 8. That is the gradient of the curve. That is how the concept of first principle is used in this particular question. Definitely go ahead and watch the video if you haven't watched it till now. Now, question number 4, a binomial question. I'll do it from scratch. So now this is the 3-step thing. It says find the term independent of x. So first of all, when we have the expansion a plus b raised to power of n, the particular term formula is what we use. That is NCR, a raised to power of n minus r, b raised to power of r. When do we use this 3-step method? We use it when the first term has an x, the second term also has an x. One will be in the numerator, one will be in the denominator. And we need to find value of r for which we will be having this term. So I write 6CR. This is x. This is 3x minus 2. It's being raised to a power of r. It's being raised to power of 6 minus r. So now let me highlight this again. So this is x minus 2. And over here, this is x and the power of x is 1. Now, this is step number 1. Step number 2, gather powers of x. So 1 into 6 minus r plus negative 2 into r, add the powers and equate it to the power of the required term. So independent of x means constant term. Therefore, x has a power of 0. So equate it to 0. Gather powers of x and equate it to power of required term. So now when we equate it for second, powers of x. So therefore, when we do this calculation, let me draw a thin line over here. So therefore, this is 1 into 6 minus r, 6 minus r minus 2r is equals to 0, 3r equals to 0. Therefore, 3r equals to 6. Therefore, r is equals to 2. Now plug in where it belongs. The third and the final step, 6c2. X raised to power of 6 minus 2 is 4. 3 over x squared, right in the normal way, raised to power of 2. 6c2 is 15. X raised to power of 4. 3 raised to power of 2 is 9. 1 over x power 4. So 15 into 9 is 135. And naturally, we can see that x power 4 in numerator, x power 4 in denominator cancels out. This is x power 0. So this is the term independent of x. This is also known as the constant term. Got the idea? So this is only 2 marks. I think it should at least be worth 3 marks. Now over here, the same question, independent of x in this thing. Now it's a bit tricky. Now you need something. What do you need? if I have 4x cubed minus 5, and if I want to multiply and I want a term independent of x, that means over here, I should be multiplying with something constant term, and I should be multiplying with something else over x cubed. Got the idea? This x cube should be multiplying with this so that the x cube and the x cube cancels out. This constant should be multiplying with this. So we already have the constant term. What else do we need? Now find out term in 1 over x cube, x raised to power of negative 3. So now this first step is the same, second step is the same, and instead of 0, I should equate it to negative 3. So 6 minus r minus 2r, 6 minus r minus 2r equals to negative 3. 6 minus 3r is negative 3, minus 3r is negative 3, negative 6, negative 9. Therefore, r comes out to be positive 3. R will always come out to be positive. Or it can also come out to be 0. R is equals to 0 means first term, R is equals to 1 means second term, R is equals to 2 means third term, and so on. So R is equals to 3. Now plug R is equals to 3 where? In this equation over here. That is 6CR. 6CR A. What is A? X raised to power of 6 minus R. And what is B? That is 3 over x squared. 3 over x squared raised to power of R. Now, when I plug in R as 3 over here, so that is 6C3. This is x raised to power of 3. And this is 3 raised to power of 3. This is x squared raised to power 3 raised to power of 3. Let me put the 3 on the outside like this. All good? Now, 6C3 is 6 into 5 and divide 20. So this thing is 20. This is x cubed. 3 raised to power of 3 is 27. X raised to power of 6. So this is 540 into 1 over x cubed. The coefficient of x cubed is 540. So now write it down. This is 4x cubed minus 5. The constant term was 135 at the top, if I'm not mistaken. Yes. And this thing is positive. Yes, it's positive. This is 540 over x cubed. Now multiply it selectively. This thing, negative 5, will multiply with this. This thing will multiply with this. So now we need the overall term independent of x. So therefore, x power 0 term, that is 4 into 135 plus negative 5 into 540. Use a calculator. Simplify. So negative, my bad, I think I multiplied the wrong things. So first of all, negative 5 into 135. And this one is 4 into 540. So therefore, this comes out to be 1485. That is the term independent of x in this expansion. All good, all clear? Question number 5. So functions came early on. It was a straightforward question, except for maybe one part. Now it says the function f is defined by fx as such and such, x is lesser than half. So let me highlight this. That is the domain. This is domain of f, that is x is lesser than half. And this fx is over here. State the value of f of minus 1. I don't know why are they asking this particular value. Let's evaluate. So f of negative 1, that is 2 into negative 1 plus 1. And this is 2 into negative 1, negative 1. So negative 2 plus 1 is negative 1. And this is negative 3 at the bottom. Therefore, this comes out to be plus 1/3. Let's double check. This is negative 2. This is negative 4. This is negative 1. And this particular value. So therefore, this value is 1/3. Okay. Now it says, second part, the diagram shows the graph of y is equals to fx. Sketch the graph of f inverse. On this diagram, show any relevant mirror line. So I think the reason why they have drawn this thing is that so you can show that this point has been flipped. And we'll just show it in a while. First of all, let me draw the green line. That is y is equals to x, something like this. Green line is better. Okay. And let me use an eraser to cut something in the middle, because you have to show that this line is dotted. So this is the mirror line. That is y is equals to x. Now, one other thing, -1 and 1/3. That will become 1/3 and -1. So that is over here, 1/3. And this is -1. So this is also a guideline so that you know that you have to go through this. This is 0 minus 1. 0 minus 1 is also there. And -1, 0. So therefore, let me mark this point, 0 minus 1 over here. And that should be -1, 0 like this. And also mark this point. That should be the common point. So now join these points like this. Hold for a second. So it's going like this. Something like this. Because there are so many black lines over here. So I think, hold for a second. First of all, let me join these two like this. That is one thing. And then you can draw it in steps. So this one is like this. And this one is a little bit like this. So I think that is not a straight line, just the curvature like this. Okay. So now this red one, that is y is equals to f inverse x. This black one, that is y is equals to fx. This is the mirror line. That is y is equals to x. Any relevant mirror line. So that's the terminology they are using nowadays. And since they both are intersecting, they should be intersecting at the line y is equals to x. Find an expression for f inverse. So now let y is equals to fx. Therefore, f inverse y equals to x. So y is equals to, this is 2x plus 1, 2x minus 1. 2x plus 1, 2x minus 1, cross multiply. 2xy minus y is 2x plus 1. 2xy minus 2x is y plus 1. X common, 2 also common. So therefore, y minus 1 is equals to y plus 1. So 2x is equals to y plus 1 over y minus 1 with the 2. So 2 times y minus 1. I think the 2 is already taken care of, or I can just do it later. Hold for a second. So now then you make x the subject. So x is equals to half bracket y plus 1 over y minus 1. But what is x equals to? F inverse y. So this is f inverse y. In other words, f inverse x is equals to half bracket y plus 1 over y minus 1. That's pure algebra. Now it's asking, state the domain for f inverse. We know that original function, let me write it, fx. Let me write over here f inverse x. Don't just ignore the colors. So now domain of f is the same thing as range of f inverse. And range of f is the same thing as domain of f inverse. So since they are asking for this thing, domain of f inverse, so let me find range of f. So in order to find range of f, I can see that it's getting close over here. We don't know what is going to happen later on, but I have a hint that this is like an asymptote. Now, how can I confirm this? I can confirm that y is equals to 1. Equate with fx. If there is a solution, that means it would be intersecting this. If the variable disappears, there is no solution. So therefore, this is 2x plus 1 over 2x minus 1. 2x plus 1 over 2x minus 1 is 1. 2x plus 1 is 2x minus 1 into 1. What happens? The 2x and the 2x cancels off. Therefore, there is no solution because variable disappears. That means y is equals to 1 is a horizontal asymptote. Got the idea? So it's just like by sheer observation that you have to do it. So now what will happen is that this is y is equals to 1. Let me mark this point. So this is y equals to 1. That is the horizontal asymptote. That means the values of y will reach 1. It won't equal to 1. So the value of the original function, f of x is less than 1. Therefore, domain of f inverse is x is less than 1. That is the answer for this particular part. Yes, this part is tricky. That is why they only have asked for 1 mark for the state, the domain. And for the expression and everything, that's like 3 marks. All this extra stuff is there. Now, some basic question. The function g is defined by gx 3x plus 2. We have to evaluate g of f of 1/4, that is over here. So this is all evaluation. No need to find an expression. Evaluate. What is fx? Fx is this thing. That is 2x plus 1, 2x minus 1. So this is 2x plus 1, 2x minus 1. If I plug in 1/4 in it, so 2 into 1/4 is half plus 1. And divided by 2 into 1/4 is half. That is half minus 1. Half plus 1 is 3 over 2. Division, half minus 1 is negative half. So 3 over 2 multiplying with negative 2 over 1, that comes out to be negative 3. Now plug in, because composite function is function of a function. Now plug in f of 1/4 in gx. So basically in gx, we are going to plug in 3, negative 3. So g of f of 1/4 is actually g of negative 3, which is 3x plus 2. 3 into minus 3 plus 2, which is minus 9 plus 2, which comes out to be negative 7. So it's worth 3 marks, but yes, there is working to it. Now this is fx. So now fx is equals to negative 7. So 2x plus 1 over 2x minus 1 is negative 7. 2x plus 1 is negative 7 into 2, negative 14x plus 7. 2x plus 14x, 16x, 7 minus 1 is 6. Therefore, x is 6 over 16, which can be written as 3 over 8. Leave the answer in the exact fraction, because fractions are beautiful. So that is how this particular question number 5 is done. Now let's look at question number 6. The diagrams look scary, but it's a straightforward simultaneous equation type of question. Now the question says the diagram shows a metal plate. Now, first of all, when you have this diagram, let me just remove this thing. Let me choose this thing and the stroke eraser like this. Now you can see over here that the dotted line is not the metal plate. This is not, this is not. There is this one radius, there is another radius, there is 2r, there is 2r, and then there is this arc length, which is identical because the values are the same, and then this arc length. All good? And then as far as sectors are concerned, there are 3 sectors. So let me just, okay, and one more thing. So now this is all just like before. The diagram shows a metal plate consisting of sectors of 2 circles, each with center O. Why does it say 2 sectors? Because the first sector is this one. They are considering this whole thing as one sector. The radii of sectors AOB and EOF, AOB and EOF, two circles. Sectors are 3, circles are 2. So this is one circle, center O, and this thing. The other circle is this thing. Of course, the whole circle is not drawn. It's just part of it. So the radius is R, angle is theta. The radius is 2R, angle is 2 theta. All these information is given. If the perimeter of the plate is 14 and the area of the plate is 10, given that R is this and theta is this, find the values of R and theta. Now, this is just scaring people. A lot of people, they have asked me what to do with this. This is used to discard values. That means if there are more than one values, so discard values according to this rule. That's it, nothing more than that. So now if I talk about this red sector, OAB, sector OAB, that is the same thing as sector OFE, sector OFE. This is exactly the same. The radius is R, the angle is theta, the arc length are SAB, SEF. SAB and SEF, that's the same, which is R theta. And the area of this sector, maybe I'll need it later, that is half R squared theta. So I have both of these things. If I talk about the blue thing, now the angle is 2 theta and the radius is 2R. So now if I talk about this thing, a sector, what's the name? OCD. OCD. So therefore, now the radius is 2R, angle is 2 theta. Arc length, let me write the arc length, that is CD, I think. Yeah. Arc length CD, that is R and theta. R is 2R, theta is 2 theta, that is 4R theta. And the area of sector, even if it's dotted, doesn't make a difference. That is half R square, that is 2R whole square into theta, which is 2 theta. This is half, this is 4R square, this is 4 theta. So therefore, no, this is not 4 theta, this is still 2 theta. So this is 4R square into 2 theta. So therefore, this is 4R square theta. Now, as far as the perimeter is concerned, perimeter of this metal plate, that is what? That is arc length AB, which is the same thing as arc length EF, and arc length CD is there. So this is this plus the radius plus 2R plus 2R. So 1, 2, 3, 4, that is 6R. So this is 6R plus R theta plus R theta plus 4R theta. So this is the blue one, 4R theta. These two are the red ones. And then all the lengths are added together. So this is 6R plus 6R theta. So that is this thing. I think there is 2R. No, hold for a second. This 2R is the whole thing. So now over here, this is still R. This 2R is the radius. Hold for a second. So over here, this thing is R only. So just use R only, just use R only. 2R is this whole thing. We don't need the whole thing. So that is one thing. So therefore, this is over here. That is 4R. So this is 4R. And this is 4R plus 6 theta. What is it equal to? 14. 4R plus 6 theta is 14. 2R plus 3 theta is 7. That is equation 1. Let's talk about the area. So now let me just push this to the corner, and that is just do this thing from the beginning. That push to the corner and then work. And I think there is more space on the next page, but I just don't want to go on the next page. So let me work over here. So now over here, area of all the sectors. That is 2 areas like this. So this is 2 times half R square theta plus 4R square theta. That comes out to be 5R square theta. All good. And this comes out to be how much? That is 10. So therefore, 5r squared theta equals to 10. That is equation 2. You can simplify it. R squared theta equals to 2. So let me push this thing, and that's the second equation. So now what we can do is that we can make one of them the subject. I can work for r. So let me make theta the subject. Theta is 2 over r squared. Plug this thing over here. So therefore, 2r plus 3 theta is 7. 2r plus 3 times 2 over r squared is equals to 7. Cross multiply. And are we getting a cubic? Yes, 2r plus 6. This is over r squared theta. And this is 6 is equals to 7r squared. Can we avoid this? I think so we can. Let me just correct myself. So first of all, this is 2r plus 3r theta. Okay, I think I forgot the r over here. No, we are not getting a cubic. I think I missed out this part. There is an r theta. I missed out over here. I missed out over here. So that is sometimes that happens. Okay. So now let me write r over here. Let me write r over here because they cannot ask a cubic and P1. So therefore, this thing over here, I can even do one other thing. This thing over here, this is r into r theta equals to 2. So therefore, if I make r theta the subject, that is 2 over r. Now plug in. So now over here, 2r plus 3r theta is equals to 7. 2r plus 3 times r theta is 2 over r is equals to 7. And then this is 2r plus 6 over r is equals to 7. 2r squared plus 6 is 7r. Yes, we getting a quadratic, and that was supposed to happen. 2r squared minus 7r plus 6 is equals to 0. And 2r squared, that's negative 3 and negative 4. So negative 4r, negative 3r plus 6 is equals to 0. 2r, r minus 2 minus 3, r minus 2 equals to 0, r minus 2. 2r minus 3 equals to 0. Therefore, r is plus 2. Therefore, r is 3 over 2. And now go back to the top. What does it say over here? R should be greater than 3 over 2. So discard the reason r should be greater than 3 over 2. So accept. So that is the only way. Now, why have they written something related to theta? Because in simultaneous, if I would have found theta first, I should choose theta lesser than 3/4, not the other way around. That is why they have written it. So be very, very clear about why you're working in a certain manner. So now r theta is 2 over r. So r theta is 2 over r. R squared theta is 2, or let me write over here, theta is 2 over r squared, r is 2. So that is 2 over 2 squared, which is 2 over 4, which is half. So therefore, theta comes out to be half. That is the answer for this particular part. Now let's look at this particular question, which is about completing square method and maybe something more. So now, first of all, what we do is that express minus 2x squared plus 8x plus 11, negative 2 common, x squared, 8 over 2. 8 over negative 2 is negative 4. 11 over negative 2, write it as 11 over negative 2. Work in fractions, keep that in mind. Always double check. Negative, positive, positive. When you take negative common out, positive, negative, negative. And yes, don't forget the x. So now this is negative 2. This is x squared minus 4x plus bracket square minus bracket square minus 11 over 2. What goes inside the bracket? Half the coefficient of x, which is negative 2, which is negative 2. Rewrite the first 3 terms as a perfect square, which is x minus 2 whole square. This is negative 4, negative 11 over 2. Open up the bracket with a negative sign. So now let me make it thicker. this will multiply with this will multiply with this will multiply with this, with each and every one of them. So therefore, this is negative 2, x minus 2 whole square plus 8, and 2 will cancel out. So that is plus 11. So therefore, this is minus 2, x minus 2 whole square plus 19. And are they asking about something else? Yes, they are asking in this format, and which means a completed square format, and they find the coordinates of the vertex of the graph with this equation. Now, the terminology. We use the terminology vertex. We use the terminology turning point. We use the terminology stationary point. They all mean the same thing. The gold standard with which we compare, that is a x minus h whole square plus k. All you have to get this thing that they're talking about completed square form. And this is the gold standard. Why? Because sometimes the examiner write a plus, sometimes the examiner write a minus, sometimes they write a minus on the outside, sometimes they write a minus over here. So why should we get confused with this? So our standard is this thing. This is a x minus h whole square plus k. If a is negative, it's upside down. It's a graph of a maxima. And minus h is minus 2. Therefore, h is 2 and k is 19. 2, 19 is your vertex. That's the coordinate of the turning point. Nothing is done. Now it says the diagram shows part of the curve with this equation and the line with this equation. Find the area of the shaded region for 5 marks. Very first thing that you should get started with this thing is that find these 2 points. Find the solution of this simultaneous equation. So now that one is the curve, which you have found earlier, but you have to solve it simultaneously. So that thing is of no use as such. Minus 2x squared plus 8x plus 11 is equals to 8x plus 9. So now life is becoming easier. 8 and 8 cancels out. Negative 2x squared plus 11 minus 9, that is plus 2, is equaling to 0. And minus 2 common. This is x squared minus 1 equals to 0. Therefore, x squared is equals to, I can even factorize also. So this is x plus 1, x minus 1 equals to 0. Therefore, x is negative 1. Therefore, x is positive 1. So this is negative 1. This is positive 1. All good, all clear? Now it's a concept of integration. So now what I can do is that I have a lot of space. So let me first work over here. Let me draw this thing, something like this. And then we have this thing, not drawn to scale. This is not drawn to scale, just to give you an idea, unlike this. When I plug in minus 1, I'll get this side. When I plug in plus 1, I'll get this side. These two are parallel sides, and this is the height. So the height is 2 units. That is from minus 1 to plus 1. That is 2 units. We have the equation of the curve. When x is negative 1, y is 8 into negative 1 plus 9. That is 1 unit. So this is 1 over here. When x is positive 1, y is 8 into 1 plus 9. 8 plus 9 is 17. So that is right over here. So basically, the coordinates are minus 1, 1. And this coordinate is 1, 17. Got the idea? So therefore, area of this trapezium, instead of integration, I love trapezium. So that is half sum of parallel sides, which is 1 plus 17 multiplied by height, which is 2. So 2 and 2 will cancel out. 1 plus 17 is 18 square units. That's the area under the line. Now let's talk about area under the curve. So area under curve. Now, either you can integrate this part, or I can use this thing also, minus 2, x minus 2 whole square plus 19. So that is negative 2, x minus 2 whole square plus 19. I can use this. And dx, and the limits are negative 1 and positive 1, and this is area under the curve. So let's use chain rule, -2 as it is, x minus 2, increase the power by 1, divide by the new power. Don't forget to divide by coefficient of x, even if it's as obvious as 1. And this 19 becomes 19x, and the limits are -1 and +1. First simplify. So -2 plus 1 is -1, -2, that cancels out, 2 bracket x minus 2 whole cube. And this is 19x between the limits, -1, +1. Now, let me first write it down. This is a big bracket. This is 2 something minus 2 whole cube plus 19 times something. Close this bracket, minus 2. Minus is taken care of. I was just worried about that. Something minus 2 whole cube plus 19 times something. Close the bracket and put this thing over here. Now, first of all, this +1, that will go over here, that will go over here, that will go over here, that will go over here. And then this -1, that will go in this place, that will go in this place. So that will go in this place, use a bracket, and over here in this place. All good, all clear? So let's continue. So big bracket, 1 minus 2 is -1, -1 cube is -1, that's 2 into -1. And this is 19. Let me write it properly. Minus -1, -2, -3, -3 cube is -27 into 2, -54. And 19 into 1 is -19. So this is -2 plus 19 plus 54 plus 19. Okay, how much is that? So let me grab my calculator. So that is 54 plus 19 plus 19 minus 2. That comes out to be 90, 90. This is 90 and this is 18. I'm just a bit skeptical. Maybe something is there. -1 and +1. The completed square form is correct. Let me just double check my working with the mark scheme. First of all, this thing is done. 5 is done. This is good. Just checking this thing first of all. So this is -2 x plus 2 whole square, 19, 2 comma 19. That is good. The limits are good. And first of all, they are doing it with subtraction. They have done individually. And it's coming out to be a very small value. Okay, this is, I think I just need to check this thing. No, this is also the expanded form. This is this thing. I think this is the one that we're using. 2/3, 19, 18, 19, maybe over here somewhere I have made a small error. Arithmetic error. So let me just go and correct the thing. So where is it? Over here. So -2 is there. And this is x minus 2 whole square. That is becoming cube. 2 plus 1 divided. Oh, here's the mistake. That negative thing, my bad. So let me correct myself. So yes, it does happen. And let me just do this mistake because the answer was very unrealistic. That's how I realized it. So therefore, divided by 2 plus 1, derivative of the bracket is 1. So now this is the mistake that I made. Let me highlight my mistake so that I don't repeat it. So this power, for some reason, I think I mixed up this minus over here. That is the reason. So now spread out your working so that it becomes easier. 2 plus 1 is 3. So this is -2/3 x minus 2 raised to power of 3 plus 19x between the limits -1 and +1. So I can just write a 1 over here. Then a big bracket, -2/3. And then something -2 whole cube plus 19 into something, close this bracket. And then -2/3, something -2 whole cube plus 19 into something. Close the bracket. First of all, plug this one. So 1 goes over here, 1 goes over here. Then plug this -1. -1 goes over here, -1 goes over here. So now let's hope for the best. So this is big bracket minus 2/3. 1 minus 2 is -1. -1 cube is -1. This is 19. I think looks good. Minus this is -2/3. And hold for a second. This is -2/3 into -1 minus 2 is -3. That is -27. And what else is there? Let me write it like this. Let me write it like this. And this is -90. So now this is all good. So -2/3 into -1, that is 2/3. This is 19. Minus sign over here, big bracket over here. And then this is 3 1s are, 3 9s are, 9 2s are 18. That is positive 18. And this is 19. So now this 2/3 plus 19, 18 minus 19 is -1, minus becomes a plus. That is 20 plus 2/3. So that is 20 2/3 units square. So now it becomes realistic. The difference between is the area of shaded region. So the difference in between the two, that is 20 2/3. This is 18. So 20 2/3 minus 18, that is 2 2/3, which comes out to be 8/3 units square. That's how this thing is done. So it was not difficult except for that minus sign error. Now here comes the main question. So now we are starting with this one. It's 8:21. What time did we start? So we solved a lot of these questions. We started at 7:21. So now we are on 8:21. That's 1 hour. And how many questions have we done? We have done 7 questions. So now 7 questions in this one with a lot of explanation. Now we are starting at 8:22 p.m. And this is now we'll be doing question 8, question 9, 10, and 11. I think there are 4 questions over here. So let's see how much time will it take. I think it would take around like 25 minutes. So let's see. So over here, let's start with this. The equation of a circle is this thing. That's in the general form, where P and Q are constants. Express the equation in this form, where A is to be given in terms of P and R square is to be given in terms of P and Q. So now it's a simple working of completing square method. Once you copy at the very first stage, do this thing. Write X with X, write Y with Y, constant, shift it to the other side. X with X, Y with Y. First add, then subtract. First add, then subtract. Square of half the coefficient of X, half the coefficient of Y. That is the first step. Just go through it. Rewrite the first 3 terms as a perfect square. These are the first 3 terms. Rewrite this thing as a perfect square. These are the first 3 terms. Rewrite this thing as a perfect square. Now over here, this thing, this orange one, this one is this one. And this minus, and this one is this one. And this Q was already shifted to this side. Now transfer this to the other side, transfer this to the other side. -1 becomes plus, P square over 4, which was negative, becomes plus, and like this. This whole thing is R square. Compare this with X minus H whole square, Y minus K whole square. The examiner could write in terms of A and B, doesn't make a difference. I have written H and K. These are the X coordinate. This is the Y coordinate of the center of the circle. So therefore, H is minus P over 2, minus H is plus. So H is minus P over 2, minus K is plus, K is -5. Now this is worth 2 marks. At least it should be worth 3 marks. The line with this equation is the tangent to the circle at point this thing. Find the equation of normal to this circle. So now this is the equation of the tangent. And then you pick the you pick the gradient. So gradient of tangent is -12. Therefore, gradient of normal is +2. We also have this coordinate. So based upon this, we find the equation of the normal. That is pretty basic, 3 marks. Now, easy thing, they have given 3 marks. Now over here, find the values of P and Q. So there are a lot of different methods given in the mark scheme. Let me just focus on the one that I consider to be the simplest. Let me draw a line over here. The first thing that I drew was that I drew a circle. I drew a realistic tangent because the tangent has a negative gradient. So that's the only thing that I've done. Then this is the center, this is A. So therefore, the gradient of this thing, if this gradient is -1/2, this gradient is +2, and this is the normal. That's the whole thing. So AC, the diameter is the normal. So let me tell you this thing. Since you are asking for the normal to the circle, so therefore this normal is basically the diameter because radius is perpendicular to tangent at point of contact. So look over here. That is the radius. That is the tangent. Extend the radius, it becomes the diameter. So now C is there, A is there, C lies on normal, method 1. I plugged in X as -P/2. I plugged in Y as -1. I found the value of P. I can also use the concept of gradient. Gradient of AC is 2. Use the gradient formula, and P comes out to be -4. P comes out to be -4. So there are 2 different ways of getting this answer. That's the alternative way. That is the first method that I have used. So I plugged in C lies on normal. That's the thing. Once you have found C, now the distance CA is the radius. We know that the distance CA is the radius. So now I have plugged in the value of P. So P is -4. And I have evaluated C as this. Now A as this. Our distance CA, that's √20. But remember, I have found that R square is this thing. That is 1 plus P square over 4 minus Q. So again, P is substituted as -4 and simplified. That is R square. This is R. So therefore, plug R over here, square it, equals to this, and you get a beautiful answer, which is Q minus 15. So sometimes the examiner makes life a bit complicated. If you look at those solutions, you won't have a good night's sleep. Yes, algebra is involved, and that is the rule nowadays. Don't expect P1 to be like a piece of cake. It won't be. Questions after 7 and 8, it will be tougher, but not necessarily conceptually tougher. It will be tougher because a lot of algebra, a lot of quadratics, as you have seen, there is a lot of simultaneous equation, lot of expansion. So it's all over the place. Question number 9. This one also was a nice question. It says the equation of the curve is this. So let me highlight this. The equation of a curve is this thing. And the equation of a line is this thing, where K and P are constant, K lying between 0 and 1. I think this examiner is too much obsessed with inequality. The first part, it says it is given that one of the points of intersection of the curve and the line has coordinates such and such. Find the value of K and P. Find the coordinates of the other point of intersection. That's for 7 marks. Easy, but lengthy. Now, the very first thing that people think is that it might be about B square minus 4AC. It's not at this stage because this is like simultaneous. So the first step, that is about simultaneous equations. So y is equals to kx plus p, that is equation 1. Y is equals to this thing, that is equation 2. We have x and y coordinate. So plug in x and y coordinate in the line equation. So that's the line equation. When you plug it, you get one thing. Then plug in, play with fractions in the which equation? This is the curve equation. So that's the line equation. That's the curve equation. Which one do you have? You have this thing. Now evaluate P. So first of all, 5K plus this thing. Now when you plug it in over here, you only have K. There is no P. So basically, you are working with this one. I'll just pause for Azan. Just hold for a second. So now, people, let's continue with this question. No, not this. It's right over here. So now the first equation has K. The line equation has K and P. The curve equation only has K. So the curve equation gives us two values of k. One is 2/5, the other one is 6/5. K lies between 0 and 1, so therefore accept this one and reject this one. Now evaluate p. Now plug in this line equation, and the value of p comes out to be -half. Make a habit of writing at the end. So therefore k is 2/5 and p is -half. So that is the first part, and that was worth 7 marks. I think it was moderate, not easy, not difficult. Now, when you go to the next page, copy the answers from the first part. So I have written the answers from the first part over here, so that I don't have to flip the pages over and over again. Now, the second part, one other thing. No. 7 marks has some other stuff also. Let me just check the thing. Yes, it's on. Okay. So now the thing is, we have to find the points of coordinates of the other point of intersection. One of them will come out to be this. We are looking for the other point. So y is equals to kx plus p. Write it, expand it like this. And that is the equation of a line. This one is the equation of the curve. Make a single equation. So basically equate. So take this thing, equate. This is one of the thing. This is the other thing. Now just look at the algebra. They are just obsessed with a lot of middle term factorization. So now middle term factorization is done. We get this thing inside. Make sure that these two are the same. Therefore, you can carry on and you are getting two answers. One answer is x is 5/2. That's given. The other answer is 25/2. Plug in the easy equation, which is the equation of the line. You find the y coordinate and hence the coordinates of this point. So that's all together, that is 7 marks. So maybe this is 4 or 5 marks, the first part, and then this part is 2 or 3 marks. Now comes the most awaited part, which is about discriminant. It is given instead that the line and the curve do not intersect. Find the set of possible values of p. But this part, it's not as straightforward as it used to be. There is a slight twist in it. Now we have two unknowns. So how can we solve? First of all, the curve equation, the line equation, what do? We make a single equation. And this single equation in terms of x, p, and k. So x is the variable, that's not the issue, but there are two unknown constants. Then you simplify. A is this thing, B is this thing, C is this thing, and then you apply b squared minus 4ac. And now here is the real part. We are getting k squared 20 plus 8p is less than 0. Now, if the product of two brackets is negative, that means either one of them is negative, correct? We have already stated k is a positive fraction. So k square will be positive. Therefore, k square will be positive. So there is no doubt about that. So this one is always positive. That means this one has to be negative. This one is this. So product is negative. Therefore, 20 plus 8p should be negative. So now solve this inequality. Therefore, p is less than -5/2. How about this question? Very tricky, very conceptual. You have to be on your toes in order to understand this. So now it was not the same straightforward thing. Just solve a simple linear inequality or quadratic inequality. It was about this concept, basic mathematical concept. This thing is done. Now let's see, are there 10 questions or are there 11? So thanks goodness, there is only this 10 question. Yes. So now let's solve this one, the last one. And then it says, what does it say? It says a function f with domain x is greater than 0 is such that the f prime x is such and such. It is given that the curve with equation y is equals to fx passes through this point. Find the equation of the normal to the curve at the point 1, 0. The first one is simple. We plug in x is equals to 1. We get y is equals to 0. I mean, that is given. My bad. That is given. x is equals to 1 is plugged in the f prime. We are getting negative 18. Now, first, when you get such a weird number, you start to doubt yourself, but expect the unexpected. So expect the unexpected, because such things do occur. Such a high value do occurs. So just trust your calculation. Yes, it's a good idea to double check. So therefore, f prime x, that's the gradient of tangent, negative 1 over 18. Therefore, gradient of normal is plus 18. So we have this coordinate 1, 0. We have this thing. And therefore, the equation is y is equals to 18x minus 18. That's the equation of the normal. Find fx. That's also some basic stuff. That is this thing. That integrate f prime x. This is done using chain rule. Just look at my working. 1/3. 1/3 plus 1 is 4/3. Division by 4/3. Division by coefficient of x. This is simple integration plus c. Simplify, simplify. Once it's simplified. So once it's simplified up till here, then you plug in the x coordinate and the y coordinate to evaluate c. And c comes out to be positive 3. Now, over here, there is also a tricky part. That tricky part is minus 1 raised to power of 4/3. How do you evaluate? Basically, a raised to power of mn can be written as a power m raised to power of n, a power n raised to power of m. So I can write this thing as minus 1 raised to power of 4 into 1/3. That is minus 1 raised to power of 1/3 raised to power of 4. That is one way. Or minus 1 raised to power of 4 raised to power of 1/3. So the cube root of negative 1 is negative 1. Negative 1 raised to an even power becomes positive. The fourth power of negative 1 is positive 1. Cube root of positive 1 is positive 1. That is how you get this answer. Or you can be very comfortable in putting it in the calculator with all the brackets and everything, you will get this answer. So that is why this thing, minus 1 raised to power of 4/3, that is coming out to be positive, and then 3 into this positive is positive. And then c comes out to be 3. Let me write this equation once more. So therefore, y is equals to 3, 2x minus 3 raised to power of 4/3 minus 6x raised to power of 5/3 plus c. And c is what? C is 3. That's the. So now let's look at this last part. Now the last part says, let me underline it. It is given that the equation f prime x equals to 0 can be expressed in this particular form. Now, this is totally one thing to express it into this particular form. So that is something extra, which I'll do it over here. How do you convert from this form, which is right over here? F prime x is 8 bracket cube root minus 10x 2/3. So let me first write it over here. So now let me do the extra stuff over here. So f prime x equals to 8 2x minus 3 cube root minus 10x raised to power of 2/3. If I make this equal to 0, so f prime x equals to 0, therefore 8 bracket 2x minus 3 raised to power of 1/3 is 10x 2/3. I took this to the other side. Now what I can do is that I can get rid of this cube root. So basically, cube both sides. If I cube both sides, this is 8 cube. This is 2x minus 3, 1/3 raised to power of 3. This is 10x 2/3. I can also write it like a bracket, raised to power of 3. And over here also, let me write this 8 on the inside. So this is 8 and then cube. Now what is happening is that this cube is applicable on this 8. This cube is applicable on this 1/3. This cube is applicable on 2/3. This cube is applicable on 10 power 1. So let me write a power 1 over here. Now when I expand it, 8 cube is 512. This is 2x minus 3. The powers cancels out. 10 raised to power of 3 is 1000. And this is x raised to power of 2. Open up the bracket. So this is 512 into 2, that is 1024x minus 1536, that is equals to 1000x cubed, 1000x squared. So now let me write a 0 over here. This is 1000x squared minus 1024x plus 1536. Now you can do the simplification. You can divide by 2, you can divide by 4, you can maximum divide by 8. So when we divide by 8, this becomes 125x squared minus 128x, and then this is 192 equals to 0. That is how we get this thing. Now, this is extra for this question, but later on for some other question, they might give you 2 marks, and they can say, show that f prime x equals to 0 reduces to ax squared plus bx plus c equals to 0, where a, b, and c are integers to be found. So now if they ask for this thing, I have already done it for you. So this is extra from my side. Now coming back to this, we already have this thing. Naturally, if it's quadratic, it has to do something with quadratic. And then it further says, determine, making your reasoning clear, whether f is an increasing function, decreasing function, or neither, for 3 marks. Now, there are different ways of doing this question. I personally favor the use of discriminant, b squared minus 4ac. So now the pen is stucking a bit. B squared minus 4ac. So a is 125. B is negative 128, C is 192. Let me evaluate this thing, which is negative 128 whole square minus 4 into 125 into 192. Grab your calculators and simplify. This is 16384. This is 96,000. You can see it for yourself that this is coming out to be a negative number. Now, that means that this equation f prime x equals to 0 has no real solution. Now, why do we solve f prime x equals to 0? So that we get stationary points. That means f prime x equals to 0 has no real solution. Therefore, there are no stationary points. Now, this thing is done. Now, remember, at the very, very beginning, sometimes they connect things to the very early on. That is over here. Let me remove all this. And this is what they have done. They have asked us to evaluate this thing, which is a function with the domain x is greater than 0. This is f prime x. They have asked for the equation of the normal at this point 1, 0. So f prime 1 is how much? Negative 18. So now the domain is x is greater than 0. F prime of 1 is negative 18. That means now connect the dots. So when we connect the dots, what do we get? We get there are no turning points and the slope is negative. That further testifies to the fact that fx is a decreasing function. So now, of course, the examiner won't be going into this much detail as I have gone. Let me show you the mark scheme. So now the last part somewhere over here. This is that thing, f prime x. And then this was the second part, the equation of the curve. Now it says these things. It says b squared minus 4ac is lesser than 0, or use of quadratic formula stating no solution, completing the square for the given quadratic and stating positive, sketch the given quadratic stating positive, no turning point in the original function. That is the basics of this. So I would stick with this one. Decreasing because f prime x is negative. So now when you connect the dots, that is the negative value that we are getting. F prime 1 is equals to negative 18, but you have to write it in words. You cannot simply state the facts at random. So you have to connect the dots the way that I've connected. Let me recap it. First of all, This is the quadratic. This is step number 1. That is b square minus 4ac is coming out to be negative. That means the conclusion is there are no turning points. Step number 2. That is this thing, that the domain is x is greater than 0. In part 1, we have already evaluated that f prime is negative. So now step 3, that is connecting the dots. That is, there are no turning points. F prime x is negative. Therefore, the function is a decreasing function. So that's how we have completed this paper, October-November 2024, variant 1-2, which was one tough paper. Stay tuned for more content.